Hello everyone, welcome in this module. In this module, we will be discussing about the basic structure of the power electronics subject, which is taught on both UG and the PG level. I am doing this recording under the Your Own Teacher Community initiative, and we provide the project guidance and the doubt clearing session on each subject related to undergraduate and the postgraduate. So if you want any kind of help, then you can reach out to our website. Okay, so let us start about the basic structure of the power electronics course. So if you look into the structure of the application of the power electronics in the power system, so it is a application kind of subject. So we have a lots of kind of application of the power electronics in like power system or the electrical machines, which are the core of the electrical machines. So this subject is taught on in the both of the like curriculum in the electrical engineering also and in the electronics engineering, electronics and the telecommunication engineering. So you will find this subject in the both of the courses. So it will be on the UG level also, on the PG level also. So as I told you, like it is a basic application subject in which like power electronics, it is referred to the control and the conversion of the electrical power by semiconductor devices. So it will be simply controlling or converting the power with the help of the semiconductor devices. If you look into the electrical machine subject, so there is another device which is known as the transformer, by which we can have a power conversion, like from one type of power to second type of power. But you have no, like if you have some kind of idea about the transformer, then you will know get to know like transformer can change only the voltage level. So if you want to convert the power from one voltage level to another voltage level, then you can use that transformer. So it will be easily converting the power from one voltage level to another voltage level. But if you want to change some kind of characteristic of that signal, like if you want to change the frequency and all those any other characteristic, then you can't do it by the power transformers. So there is another field of the this power electronics application in which we can convert the power from one type to another type. So it can be like voltage conversion or it can be like frequency conversion. So simply the power electronics is a application kind of thing by which we will be using in the field of the power system or maybe in the electrical machines, or sometimes like it is also used in like IC manufacturing and all those fields also. So it is like a application a kind of thing. So in the starting of this like power electronics, when the era of the power electronics were started, then before this we were using mercury arc as a rectifier, like for on the place of this SCR, which is known as the silicon controlled rectifier. So though before this invention of this SCR and power electronic switches, we use a mercury arc rectifier where we used it for the control of the electrical power. But that was not much reliable and also not much robust as the power electronic switch. So after when the first switch are invented in the power electronic system, after that there is lots of kind of switches like MOSFET, BJT, IGBT and TRIAC and all those devices were invented, and like it is like also a field of research till now, like how we can improve the performance of the power any power control devices by help of the power electronics. So all the study will be done in the this power electronics course. So let us proceed further and look into what will be there in the power electronics course. So if you look in about the power electronics, then it is like related to the control of the flow of electrical energy. So it will be controlling the flow of the electrical energy. So we will be using some kind of power electronic devices by which we can control the electrical flow of the electrical energy. So there will be a lots of kind of power electronic switches or capacitor, magnetics like inductor and control system. So all these elements will be there in the power electronic devices. So different kind of power electronic devices are taught on the undergraduate level, and their analysis is also there. So if you have to start about the power electronics, then you have to know about the basic characteristic of these kind of basic switches. Switches means like power electronic devices. Like if you talk about the power electronic switches, then it will be coming like BJT, MOSFET, IGBT or TRIAC. So you have to know about this first. The preliminary for this course is you have to know about the basic of these switches. So you have to know about the basic characteristic, how they turn on, how they turn off. So like what are their characteristics. So these things we will be starting from the basics so that you will get to some idea like how these switches are controlled. So if you look into the scope of the power electronics, then if you look on like if you try to like write the power electronics on the basis of the power level, then if you look into like low power level from 0 to 10 watt, then it will be like battery operated system like small batteries. And if you go from 10 to 100, then it will be like satellite power system and typically offline flyback supply. So these are like scope of the power electronics. So if you look into like 1 to 10 kilowatt, then it's look like hot tub. And like these are the examples of the like power level in the power electronics. So after 1 gigawatt, we generally consider like so 100 megawatt to 1 gigawatt. We generally consider the power plants. So in these systems, we will be using the power electronics to improve their performance. So it is like kind of application of the power electronics we can use to improve the performance of like these general equipments. So let us proceed further. So this power electronics subject will be conveying like a multiple subject you have to know about this. Like some primarily like prerequisite will be required for this course. So it will be requiring like circuit theory. Like circuit theory, we have to some basic ideas to like go with the power electronics course. We have to know about something about the circuit theory. So like basic KBL and KCL, these things you have to know about. Like this is the like prerequisite of the course. So so control theory, system and the control theory, signal processing, basic electronics. Basic electronics means you have to know about the switches and their characteristic. Electromagnetics, like you have to know about the flux also, because in the most many power electronics devices you will be using the transformers. So you have to know some basic idea about the power electronics and the power system, electrical machines and simulation and the computing and solid state physics. So these are the like basic things you have to know before starting the power electronics. So this will be also required like as a prerequisite for this course. So as it is like very advanced course, that's why it is like sometimes in the on the UG level it is taught on the third or fourth year generally. So because it requires a lots of like prerequisites. So let us move further and see what are the application of that power electronics. So there are lots of like if you look any electrical equipment, then you will definitely find some kind of power electronics in that. So as of nowadays you will look like most of the electrical devices containing some power electronics control, because it is very beneficial for us to control the power through the power electronics. So it will give a huge reliability to us so that we can control the power through that electrical equipment. So if you look into the heating and the lighting control, like any kind of heater or lighting, then you will be having some kind of power electronics will be there in the starting, so that you can control the heating, like how much heat you required, or these things will be easily controlled by the power electronics devices. So there are lots of application is written over here. If you look into like heating, induction heating and uninterrupted like UPS, it is generally normally in used in your like daily life. You have seen like in UPS you have around you. So it is like main core part of the UPS is the power electronics. So if you look into that, like by which you will be charging your battery or discharging your battery by through that power electronics. So it is like a core part of this UPS. So after this, if you look like there are fluorescent lamp, blaster, passive and active. After that, electrical power transmission and all those like alternator, electrical storage, electrical vehicle, and all those things needed the power electronics control over their application. So with the power electronics control, we have a like huge reliability to control the power in a very easy methods. So that's why it is a like a very big field of research. So that like we can improve the performance of the electrical or electronics devices. So like let us see about what will be the there in the power electronics. If you gone through with the like devices characteristic and all those preliminary, then it comes about the core part of this course. So if you have some idea about the switches and all those things, then there will be three kind of things we will be doing under the power electronics. One is the DC to AC conversion, second one is the DC to AC conversion, and third one is the AC to AC conversion. So if you have some kind of DC supply and you want some kind of AC supply, then you will be using this DC to AC conversion. So it is known as a inversion process, because you have the DC and you want to convert it in the AC, then it is known as the inverter. So like in UPS, if you are charging your battery from the AC, then it is known as the rectification process. Converting from the AC to DC is known as the rectification, and converting from DC to AC, it is known as a inversion. So like process of converting, like the host device convert the AC supply to DC supply is known as the rectifier, and the device which convert the DC supply to AC supply is known as the inverter. And this the device which is converting the DC to DC, like from DC supply to one level of DC supply to another level of DC supply, is known as the chopper. So these are three main devices which we will be using in the power electronics for our study. So if you look into the DC to AC conversion, then there will be lots of kind of devices as per your requirement. So we will be looking into their performance and their input output relations and all those things. So if you look into DC to AC converter, then there will be a lots of device like single phase inverter, three-phase inverter, and multi-level inverter. So there will be lots of devices, and we will be having to look into that, like how they are working, or how which type of like the characteristic input output relation, and when in which mode they are using working. So these things you have to look into. So if you talk about this DC to DC conversion, then you may require three kind of work. So if you want to step up the DC, or if you want to step down the DC, or if you want to both. So on the basis of the requirement, there will be three kind of devices. One is the step up chopper, second one is the step down chopper, and third one which is having the both capability, like stepping up or stepping down both. So uh, we like generally on the UG level, we have to learn about three kind of devices. One is the buck converter, second one is the boost converter, and third one is the buck boost converter. So by buck converter, we can reduce the DC level. Like if you have high voltage DC and you want to convert it on the low voltage DC, then you can use the buck converter, and by controlling the switch which will be there inside the buck converter, that duty ratio of the switch, you can control the like DC supply, like what do you want on the output side, you can easily control by that switch. So buck converter is used to step down the DC voltage level, and the boost converter is used as a to step up the voltage level. So if you have some kind of DC which is slightly lower level as per your requirement, so and you want to step up that DC, then you can use the boost converter. So by boost converter, by controlling that switch which will be inside that uh, converter, so you can like boost the DC voltage level from lower level to higher level. And the buck boost converter is simply a mixture of these two devices, and you can do both. Like buck means like step down, or boost means step up. So you can do the both things with this buck boost converter. So if you have the buck boost converter, then you can easily step down the voltage or step up the voltage by that. So we will be looking for all three in these three devices. We will be looking like input output relation, like how much duty ratio for, like if you have some kind of duty ratio for the device, then what will be the output of the this converter in the terms of the input. So we will be looking into the input output relation. We will be looking into the waveforms, like what is the device current or output current. So these waveforms you have to analyze. If you go through the course structure, then you have to analyze about these waveforms, like input current, output current, input voltage, output voltage, switch current, switch voltage, all those, like every element which will be there inside the converter, you have to analyze its current and the voltage also. So by analysis, you will find like what, like some kind of critical condition, like on which the converter will be working. So you have to find out all those elements value also, and there will be some kind of design also, like you have to you in some kind of numerical, you have to ask to design some kind of converter like DC to DC converter. Like if you ask to choose some kind of design some kind of chopper, then they will be giving some kind of requirement like you have this kind much of input and you be required this much of kind of output, and you have to design for that any you have to design any chopper for that. So you have to find out the value of that switching frequency for that device. You have to decide, and after that you have to decide about the switching frequency and switching like duty ratio for that device and the value of the capacitor and the inductance on the basis of the voltage and the current ripple. So voltage ripple is decided by the rating of that capacitor. It like restrict the voltage ripple, so it is connected across the output so that the voltage ripple across the output do not get violated. So voltage ripple is decided by the this capacitor, and the current ripple in the output is it is controlled by the inductor. So if you choose some like you have to choose some kind of inductor for that design so that the current ripple do not goes beyond the limit. So uh, you have to find out the value of those capacitor and the inductor. So in the design problem you have to find out these kind of things. So after that DC to DC conversion, we have the AC to AC conversion. So it is known as the AC regulator. So if you look into the fan volt AC regulator, then you will find like in your like daily life, you will be using this kind of device, AC to AC conversion, by which we are controlling our fan. So that is known as the AC to AC conversion, by which we will be converting the AC supply to another level, or maybe we will be changing the voltage level of that AC, or maybe we will be changing the frequency of that AC input. So if you have some kind of AC on your input side and you require some kind of AC on your the output of this a power electronics converter, then you can use this AC to AC conversion. So in the AC to AC conversion, maybe you will be varying the voltage level of that AC input AC, or maybe you will be varying the frequency level of that AC. So in a lots of application, you need to vary the frequency, and you have to only option by which we can vary the frequency is the power electronics converter, because you know the voltage that transformer which we used to learn in the electrical machine, that cannot convert the frequency, and that can only convert the voltage level. So only device which can convert the frequency level is power electronic devices. So we will be using the power electronic devices to change over in the frequency. So there are lots of application which is in the used in the control. Some kind times you have noted down like to control the electrical machines, we need variable frequency drives. So if we need the variable frequency to control the speed of that machines, then we will be using to the AC to AC conversion, by which we will be controlling the electrical machines. So these are the like three main parts, which is power electronics is divided in these three main part, and we will be learning about the various devices. Like you can categorize all those devices in between these three kind of devices. So like for AC to the AC converter, there will be many kinds of configuration of the power electronic devices, which we will be learning in the course structure. So there will be a lots of devices under these three categories. So let us move further and see some like example of the power electronics. So let us take some example of the photovoltaics. So you have some PV array by which you will be absorbing the sun energy from the sun, and you have to control that energy by some kind of controller. So you will be having some like PV array, and you will be absorbing the sun energy, and by this solar controller you will be controlling the like this parts you will be controlling. And after that this DC DC kind of power will be given to the battery bank, and this battery bank will be like storing the electrical power. So after that you like all the usable things are running on the AC system, like all the equipment which is are used in your daily life or anything. So most of the equipment runs on the AC, so you need AC, not the DC, because that battery will be storing the energy in the form of DC, and you want some kind of AC on your for your requirement, then you will be having some requirement of the DC to AC conversion. This first one we will be using here, and we will be converting the DC, which will be like stored into the this battery bank, and we will be converting it into the AC, and we will be getting some kind of AC here. So this is how we will be using the power electronics to convert the DC to AC. So this is one of the examples in which we will be using the power electronic switch. So sometimes these type of things also taught in the power electronics itself, in which we have to control the solar PV by the means of the power electronics converters. So these things is also covered under the power electronics, because the main part of this complete conversion is the power electronics, because like it is the main part where we will be applying our control. So let us talk about something about the converter. So power electronics converter, that it is referred to a power electronic circuit that convert the voltage and the current from one to another. Sometimes there will be some frequency also, because sometimes we will be converting the voltage, sometimes it will be current, sometimes it may be frequency. So this is always written over here, which we have already discussed, like rectifier converting the AC to DC, inverter converting to DC to AC, and chopper switches the voltage level from one DC voltage level to another, and cyclo converter is used as a frequency controller, like from one frequency level to another frequency level. So let us talk about the rectifiers. What types of device will be there on the rectifiers? So I have told you there are lots of kind of rectifier which we will be using into the power electronics subject. So as per the requirement, you can choose one of these and you can use as a rectifier. So if you look into, like, if you talk on the same single phase level, then you have the single phase semi controlled bridge rectifier. So this is the first of the rectifier. So you have the single phase semi controlled bridge rectifier, or you have single phase fully controlled bridge rectifier. So you will be using four devices in the semi control and the full control, and you will be having like some kind of semi control structure in the single this first one, and you will be having the full control over the voltage range in the second one. So in the both you will be using four devices. So if you go into the details of these devices, then you will be find like what are the basic difference between these two devices. Then after that you will be going to three phase to like three phase conversion. Like if you have three phase AC supply and you want to convert it into the DC, then you have three phase rectifiers, like three phase half wave rectifier, and other is the three phase single full wave rectifier. So on the basis of like use of the devices, there will be two kind of rectifier on the three phase also. So one is the half wave and another is the full wave. So also there will be some kind of semi control and fully control on the basis of the use of those devices. So this is what we will be going through with the in the rectifier. Let us move to the DC to AC converter. Like we have already uh, uh, talk about this, like DC to AC conversion is known as the inversion process. So by the means of the inverter, we will be converting the DC into the AC. So there will be lots of kind of inverter we will be using in from to convert the DC into AC. That is like a single phase inverter, three phase inverter, or maybe sometimes we will be using multi-level inverter also to convert the DC into the AC. If you look for the application of that DC to AC conversion, then you will find like emergency lighting system like UPS. You will be using the DC to AC variable speed drive. You will be using the DC to AC, and this UPS is written over here, and the frequency converter is also categorized under the DC to AC conversion. So let us move further and look into the like DC to DC conversion. So DC to DC conversion, it is like known as the chopping process, in which we will be like converting the DC voltage level to another one DC voltage level to another voltage DC level. So if you look into the like a type of devices which we will be using into the DC to DC conversion, then it will be like a step down switch mode power supply. So it will be like a step down, that is known as the buck process, and this step up is known as the boost. So sometimes we use these two devices as a single one, and it is known as the buck boost, which will be capable of step up and step down the voltage level. And apart from these three devices, we have some flyback converter and the resonant converter, which is also there in the DC to DC conversion. So these two are the very much advanced devices like flyback and the resonant converter. So it is not sometimes where will be there on the UG level. So it is taught on the PG level only, that flyback and the resonant converter. So these first three, like buck boost and the buck boost converter, are like main devices which will be there in the DC to DC conversion. So let us move toward the AC to AC conversion. So there will be like one device which is known as the cyclo converter, which will be converting the AC supply to AC supply. So if we want to change the voltage level of that AC, or if we want to change the frequency of that input AC, then we will be using that cyclo converter. So cyclo converter are like known as a like frequency changer or the voltage changer. So some, if you need some kind of voltage changeover or frequency changeover, then you can use the cyclo converter. And mostly which device will be used in the cyclo converter is known as the triac. So triac is the like very famous device which is bidirectional. So most of the device which is available in the power electronics is a unidirectional. Like you can, like the flow of the current is allowed only one direction. Like if you talk about the BJT or MOSFET or IGBT, then these are the unidirectional device in which the direction of the current will be only the in one direction. You can't, like it will not allow the flow of the current in the opposite direction. When you turn on the device through the gate or maybe some kind times through the source, then it will allow the flow of the current in one direction, which will be like pre-specified. But the triac is the one device which allows the flow of the current in the both the direction. If you give the suitable gate current to it, then it will allow the flow of the current in the both direction, like either in the uh, going direction or in the upcoming direction. So triac is mostly used in the AC to AC conversion, so that like it is if you talk about the manufacturing of the triac, then it is simply the combination of the two switches which are connected into the back in the opposite to each other. So if they are connected in the opposite, then one device can connect one device will be uh, flowing the current in one direction and other will be allowing the current in the opposite direction. So we simply add two devices in the opposite, and one device will be responsible for conducting in the forward direction, and another device, the second device will be responsible for the conduction in the opposite direction. So this is about the AC to AC conversion. And application of the power electronics, we have already talked. Like if you look into the your like conventional car, then all those automobile having the mechanical engines. But nowadays we are like switching to the electrical vehicles. So in electrical vehicle, we need like some kind of charger to charge the battery, and after that we will be using to that DC supply as a AC. So we have to convert that DC into the AC. So there will be a lots of power electronics application, and it will be like a huge area of the research also, so that we can improve the performance. So these are the like some kind of application of that power electronics. So all these things will be covered under the like these devices will be covered under this power electronics course. And we will be trying to find out like the input output relation of those device converters, like what is, if we give some kind of input, then how much output we will be getting. And if we give like we will be trying to, there will be lots of kind of waveforms also we have to draw. Like we will be drawing the uh, you have to ask, like sometimes in the exams also they ask about the waveforms, like what are the waveforms of the current or voltage across any, like there will be lots of elements in the power electronics converter. Then maybe you will be asked to draw some kind of waveform, what are the waveforms of current and voltage. So you have to draw that waveforms. So apart from that input output relation, these waveforms are also important, and you have to sometimes find out the expression of the current and the voltage. You have to, so you have to find out the expression of the voltage and the current. So these are the things which we have to do into the this power electronics course. And sometimes that's why it required the prerequisite at the networks, because you will be using the network most frequently into the analysis of this converter like KVL, KCL, and all those law which is used in the electrical networks. Those are like very frequently used in the power electronics. So we will be going through those, and we will be trying to find out the what are the expression of the current and the voltages. So beyond like this, on the PG level, you will be some kind of like advanced converter also, like multi-level converter, or some kind of like flyback we have also talked. So these are taught on the PG level, in which like a advanced analysis and the modeling of the converters also do. So if you have some kind of converter and you want to find out the you want to model that converter into the like mathematical modeling of those converter, then this will be also covered under the power electronics course. So these things we will be covering under the power electronics course. So if you want like any kind of help regarding this subject, then you can reach out to us. We will be there to help you on any kind of like project or any kind of doubt clearing. So if you want any kind of help regarding this subject or any subject on the UG and PG level, then we are here to help you. You can reach out to us on this like our website, and we will be very happy to help you. And thank you for joining this session. We will be meeting in the next session. Thank you.